Okay, so we're going to take a look at an application of the modulus operation. And we're going to be using some binary numbers in this, and also just take a look at some things that we can do with numbers. So we'll actually have two examples in this program. So the first thing that we're going to do is we're going to have the user enter a number. And then what we're going to do is we are going to show them the digits of that number. So here, enter a 3-digit number. Okay. So now what we're going to do for this is we're going to show all three of those digits of the number on different lines. So we're not going to display the number yet. So what I want to do is we're going to see out. Now, how do we get the last digit from n? So imagine that n is, say, 365. We'll go with that number. Now, what I want on this line is I want the 5 displayed. So that's the last digit. So what I need to do here is I need the remainder of a division by 10. So what happens is if I divide this by 10 like using long division, it would give me 36 with a remainder of 5. So whenever you divide by 10, the remainder is going to be the last digit of the number. At least that's in a base 10 operation. So what we're going to do here is we want to display n modulus 10. So if I run this, and I'm going to go with 365 as the example. So 365 gives me 5. Now what I want to do is I want to put the 6 on the row beneath it, but how do I do this? I can't do this. I can't do cout n modulus 100, because watch what happens. If I go 365, should have put an NL here to show that a little bit better. Enter the 3-digit number, 365. I get 5, and then modulus 100 gives me 65. What I actually have to do is get rid of the 5. So what we're going to do here is n is going to get the value of n divided by 10. So we've learned that in an integer division, it can't hold on to the decimal place. So this will effectively remove last digit. So this line will display last digit, and then the line after it will remove the last digit. So if I had 365 and I remove the last digit, then I've got 36. So which digit of 36 do I want to do? Well, I want to display the last digit, and then I want to get rid of that digit. So I'm going to do it this way. Copy, paste. And it's 3 digits, so I'm going to copy and paste again. So 365 gives me 563. Now the other thing to note here is because I have one step after the result, just to show you what this does, I'll show you what's left of n afterwards. So if n only has the number 3, and then we divide it by 10, 365, it will be a 0 at the end. So I'm going to remove this line of code, though, and keep the rest. Okay, so now how are we going to use this style of programming to do a conversion from a decimal number to a binary number? I typically don't do this, but I'm going to declare some variables here because this is kind of like a second part of the program. So I'm going to have a decimal number, and I also need a binary number. So what's important here, and we're going to go over this a little bit more later, that binary number is going to have to start at 0, and then we're going to construct it as we go. Okay, and we need to keep track of which place value we are putting a number onto. So the place value is going to be important, and we'll see how that fits in. So step 1, prompt for a decimal number. So enter a decimal number. Don't need an ANDL here. So cin decimal number. There we go. Now what I want to do is I want to use the divide by 2 algorithm. So the divide by 2 algorithm that we have learned to convert the decimal number into a binary number. So what we do is we're going to take the decimal number. And remember, the thing that we care about isn't the result of the division by 2, but it's the remainder of the division by 2. So for that, we have to use modulus 2. Okay, now we've got whatever remainder the first division gives us, but where do we put it? So we are adding it on to the binary number. So the binary number is going to get the value of the binary number plus the decimal number divided by 2. So we'll just do this as a quick example. So we're going to see out the binary number. So if I put in, so it's going to show up under my 365. So we'll go 365, and then imagine I want 365 to be my my binary number conversion. So we know that the first division is going to give is an odd number, so it gives us a remainder of 1. So we've got that, no problem. Now, the thing is with the next division, we don't want to add a 1 on to here. We want to say, like, if it's an odd number again, we want to put that into what would be the tens place. If we're treating this like a decimal number, we kind of have to. So here's what happens is we are going to use place to maintain which place value we are going to be putting this into. Okay, so now that I've got that, I've got my remainder. I actually do have to divide the decimal number by 2. So the decimal number is going to get the value of the decimal number divided by 2. Now all we have to do is we have to do this whole thing again. So I'm going to copy and paste. But the only difference between this step and this step is we have to make sure that the place value gets shifted over. So whatever we get for the second part of the calculation doesn't get put in the ones place, it gets put in the tens place next to it. So every time we do this, we're going to have place become place times 10. So here it'll be putting it in the ones place, and then here it'll be putting in the tens place. And then we just have to simply repeat this a whole bunch of times. So this would be in the ones place multiplied by 10. This one will be putting it in the tens place. This one will be putting it in the hundreds place. This one will be putting it in the thousands place. So if I run this, let's think of a number that's small enough. Let's go with 11. So, 365. And then I'm going to do, you know what, I'm going to do 13. 13. Let's take a look at that. So 13 gives us 1101. So that's 1 plus 4, which is 5, plus 8 gives us 13. And it does that because the first remainder is put in the ones place. The second remainder is going to be put in the tens place. And then the next remainder is going to be put in the hundreds place. And the next one is in the thousands. Now, here's the problem is that we don't know how big the number is going to be. But thankfully, it's not going to matter too much because all we have to do is take this algorithm and keep putting it on, because this will put it in the 10,000s place. So imagine we've run out of numbers already. We went with 13. So what happens here then is we divide that last by 2. And remember, at the bottom of the calculation, when you divide up 1 by 2, you get 0 with a remainder of 1. So you'd get 0, 0, 0 all the way through. So this would be in the 10,000s. This would be in the 100,000s. And I'm just going to keep putting my zeros here. There we go. I lost track. But anyway, you get the idea. So let's see what happens when I put 13 in again. Oh, okay. I've got some sort of connection error here, which is always fun. Okay, I'm back here. So what happens here is when we do all of these divisions, even if I put in the number 13, 365, I put in 13, we're going to have a whole bunch of leading zeros. So when it's done this step, it just has a bunch of zeros to tack on at the end, and that doesn't get displayed because the numbers don't display leading zeros. So by putting this a whole bunch of times, we can run this, and 365, and then our decimal number, if I put in something a little bit larger, say 212, we do get the result for 212 here. Now this has a bit of a limitation because integers have a maximum size that they can hold. So you can only go so far with this number, but it's a good example of following an algorithm, although when we learn how to loop code, this program is going to get a whole lot cleaner.